Hello friends and my dear students, I welcome you all to my channel. I hope you're all well and your studies are also going on well. This is, I'm starting the new chapter which is linear equations into variables. This is part 1 video where I will be discussing about the format of a linear equation into variables and the solution of a linear equation into variables. I won't be solving any problems. I will just discuss few concepts with probably some examples. And in the next video, I will solve a lot of problems. So this video is part of the playlist CBSE Maths for class 9, following the textbook of author RD Sharma. If you find this video beneficial, then please like it, share it with your friends. And once again, if you want to further support me, then please subscribe to my channel. And in that case, do not forget to press the bell icon so that you will be notified by my future videos. Okay. So, what is what is a linear equation in two variables x and y? How it looks? It is of the format ax plus by plus c is equal to 0, where a, b, and c are some real constants. Now, I have written that in this format, that is a comma b comma c belongs to this symbol is looks like e, it is epsilon, belongs to r, means if r is the set of all real numbers, which is basically an infinite set. We know that r is a the r denotes all the real numbers, and all real numbers can be represented as a infinite set. So abc are basically real constants, but a and b are not equals to 0. Both a and b has to be not equals to 0. Only then we can consider ax plus by plus c equals to 0 to be a linear equation in two variables x and y. Okay. Now, a linear equation in two variables x and y could initially be given, can be given in some other format. But by rearranging them, any linear equation in two variables x and y eventually can be written in this format. Let's say, let's see some examples. Let's say x minus y divided by 2 is equal to 3. This is a linear equation in two variables x and y, but it is not in this format. But we can easily convert it into this format. How? We can say, doing cross multiplication, x minus y is equal to 6, and I can bring the 6 to the left hand side. I will bring everything to the left hand side, and so the right hand side will be 0. So this is x minus y minus 6 is equal to 0. So now in this example, we see what is a. A is 1. What is b? B is minus 1. And what is c? C is minus 6. Let's see another example. Let's say root 3 by 2 y plus x, let's say, is equal to 4 plus 5x. This is a linear equation in two variables x and y. Let's see how we can convert it into the uh, general format, that is ax plus by plus c equals to 0. I will bring everything to the left hand side. That will, uh, and then we will have root 3 by 2 y minus 5x minus 4 is equal to 0. Now, doing a little bit of arrangement, minus 5x, I have minus 5x plus root 3 by 2 y minus, or even better, if I write it this way, it will be more easy to understand. I can write now minus 5 into x plus root 3 by 2 into y plus minus 4 is equal to 0. So now we see this is in the format of ax plus by plus c equals to 0, where obviously we see a is equal to minus 5, b is equal to root 3 by 2, and c is equal to minus 4. So in this way, there could be linear linear equation in two variables x and y could be in any format, but eventually we can rearranging them. We can rearrange the terms and bring it everything on the left hand side and doing a little bit of manipulation, like we can multiply in an equation. We can multiply both the LHS and RHS and divide by some non-zero constant. Doing all these operations, eventually we can convert any equation of any linear equation in two variables x and y in this format. Okay, let's see the next point. Uh, an ordered pair x1 comma y1, where x1 and y1 are some x1 y1 are real numbers, are real constants, belongs to R. Whenever I will say x1 comma y1 belongs to R, it means that x1 y1 are some real constant, a real constant value. So an ordered pair, it is important that ordered pair, first we are having x1 an ordered pair, let's say x1 comma y1, where x1 and y1 are some real values uh, of an ordered pair x1 comma y1 of values of the variables x and y is said to satisfy the equation ax plus by plus c equals to 0 if we have, if in the equation ax plus by plus c equals to 0, if I substitute x with the, now the ordered pair, in the ordered pair x1 comma y1, x1 represents the value of the variable x and the y1 represents the value of the variable y. So if I substitute x with x1 and y with y1 in the given equation, it must satisfy. That is, the LHS should be equal to RHS. I mean, in the standard format, the RHS is always 0. I must have AX1, that is AX1 plus BY1 plus C equals to 0. Then we say that the ordered pair X1 comma Y1 uh, uh, satisfies the linear equation ax plus by plus c equals to 0. Now, this ordered pair x1 comma y1 is also conveniently written in some books as x equals to x1 and comma y equals to y1. X equals to x1 comma y equals to y1 is more understandable, is more readable, but in short form we also, or in short form we write it as x1 comma y1, where we mean that the first value in the ordered pair, the first value, that is x1, stands for the value of the variable x. The second value, that is y1, stands for the value of the variable y. Okay, now let's say okay, so mm, okay, uh, now can we say that minus 1, this ordered pair minus 1 uh, satisfies the linear equation, let's say x minus 2y plus 1 equals to 0, like true or false? If we are asked whether to investigate whether the ordered pair minus 1 comma 2 satisfies the equation, linear equation in two variables x and y, which is given as x minus 2y plus y equals to 0, how do we investigate? We will put minus 1 as the value of x and 2 as the value of y in the equation, and we will see whether the LHS is coming to 0 or not. When I say the LHS is coming to 0 or not, when once we have transformed the given linear equation in the format ax plus by plus c equals to 0. Initially, the linear equation could be given in any other format. First, we have to convert. It is better, it is recommended that you convert any linear equation into variables in the standard format, which is ax plus by plus c equals to 0. Now, if I now substitute minus y, so LHS is equal to minus y minus 2, y is 2 plus 1. This is minus 1 minus 2 plus 1. This is minus 2. This is not equals to 0. So therefore, the statement that minus 1 comma 2 satisfies the linear equation x minus 2y plus 1 equals to 0. This is a false statement. This is a false statement. Okay. Uh, okay. Can we say that 4 comma 2 satisfies 4 comma 2 satisfies the linear equation uh, x minus 2y equals to 0. Now, remember that the standard form of the linear equation in two variables ax plus by plus c equals to 0, c can be 0, but a and b should not be 0. So, in this is the linear equation in two variables where we see c is 0. C is 0. In this linear equation, we see that a is equal to 1, b is equal to minus 2, and c is equal to 0. Now, if I want to investigate whether the ordered pair 4 comma 2 satisfies the linear equation x minus 2y equals to 0, what I will do is I will see whether the LHS, the value of the LHS after putting the value of x as 4 and the value of y as 2, it is coming to 0 or not. 4 minus 2, 2. This is 4 minus 4, it is 2. So, 4 comma 2 satisfies the linear equation x minus 2y is equal to 0. So, this is all about whether an ordered pair satisfies given linear equation in x1 y, where in the ordered pair the first value represents the value of the x and the second value represents the value of the variable y. Okay. Let's see the next concept or point is an ordered pair x1 comma y1 is a solution or root of the equation ax plus by plus c equals to 0 if it satisfies the equation. So we say that an ordered pair x comma x1 comma y1, where obviously x1 and y1 is some real constant. Whenever I mean to say that x1, any number, whenever I mean to say that, let's say any k is a real constant number, mathematically, I will write it as write it this as k belongs to capital R. Capital R represents the set of all real numbers. So k belongs to R means k is a real number, real constant number. Okay. So we say that an ordered pair x1 comma y1, where x1 y1 are some real numbers, is a solution or root of a given linear equation in two variables ax plus by plus c equals to 0 if it satisfies the equation. Which so essentially, if we have ax1 plus by1 plus c equals to 0, then we can say that x1 comma y1 is a root or solution of the linear equation ax plus by plus c equals to 0. Okay. Now, can we say that, let's say there is a linear equation x plus y minus 1 is equal to 0. So, is minus 1, 1 a root of this? Can we say, is it true that minus 1 and 1 is a root of the linear equation x plus y minus 1 equals to 0? How will I know whether it's a root or not? I will I will find the value of the LHS. Remember that first I will convert the given linear equation in the standard form, that is ax plus by plus c equals to 0. This equation is already in the standard form. So LHS is, after substituting a value of minus 1 for x and 1 for y, I have minus 1 plus 1 minus 1. This is minus 1 and not equals to 0. So minus 1 comma 1 is not a root. No, is not a root of the linear equation x plus y minus 1 equals to 0. Okay. So can I say 3 comma 2 is a root of the same linear equation x plus y minus 1 equals to 0. how do I how will I investigate? I will find the LHS of the given linear equation in the standard form by I will find the value of the LHS of the given linear equation in the standard form by substituting the value by substituting 3 for x and 2 for y. So this is 3 plus 2 minus 1, which is equal to um, uh, I think I did something wrong. Let's say the linear equation is x plus y minus 5 equals to 0. Then I have LHS, that is, if I want to find the value of the LHS after substituting x with the 3 and y with 2, that is, if I want to find the value of the LHS of the given linear equation by substituting the given values of x and y from the ordered pair. So this I can see is 0. So I can say that 3 comma 2 is the root of the linear equation x plus y minus 5 is equal to 0. Okay. So the concept is that whenever it is given that x1 comma y1 is a root or solution of a linear equation ax plus by plus c equals to 0, then what result we can say? We can immediately say we will immediately have ax1 plus by1 plus c equals to 0. This result we will get, and from this equation, whatever we need to find as per the given problem, we will proceed accordingly. Okay. The next concept is that a linear equation ax plus by plus c equals to 0 has infinite number of solutions or roots. Why is it so? Why any given linear equation of the form ax plus by plus c equals to 0 has infinite number of solutions means there will be infinite number of ordered pairs x1 comma y1 which will satisfy the given linear equation ax plus by plus c equals to 0. The reason is that let's say you choose any real value of x. Say that value is x1, and if you put in the linear equation, given linear equation ax plus by plus c equals to 0, if you substitute x with the value x1, then you will get a linear equation in y. From there, you can solve for y. And the solution, if that solution is y1, then you will have y1 is equal to minus negative of ax1 plus c whole divided by b. So then we can say that x1 comma y1 is then obviously x1 comma y1 will be a root of the equation ax plus by plus c equals to 0, where I have chosen x1 as any random real number. Okay. Now x1 is one such real number that I have chosen. I can similarly I can choose infinite number of real numbers are possible to choose for as x1, since there are infinite number of real numbers. Since there are infinite number of real numbers, the x1 I'm choosing a value of x1, which is I'm choosing a value of the variable x as x1. This x1 can have the infinite number of I can choose x1 for x1. I can choose there are infinite number of real numbers that I can choose as x1, and for each such x1 I will definitely get a y1 I will get a y1 which will be equal to negative of ax1 plus c by divided by the whole divided by b when the given linear equation is ax plus by plus c equals to 0. Then x1 comma y1 will be a root of the linear equation ax plus by plus c equals to 0. Now since there are infinite number of possibilities of infinite number of values of x1, since there are infinite number of real numbers, I will get infinite number of corresponding values of y1. And hence, we can see that I will have infinite number of ordered pairs x1 comma y1, which will be definitely a root of the given linear equation. Hence, we see that any given linear equation of the form ax plus by plus c equals to 0 will have infinite number of roots or solution. For example, let's say the linear equation is given as 2x plus 3y minus 1 is equals to 0. This is the given linear equation, and let's say we are asked to find a root of this linear equation. A root of this linear equation means I have to find an ordered pair x1 comma y1 that will satisfy this linear equation. So let's say I will assume any real number value for x1. So let's say x1 is equal to, let's say, 9. Okay. Now I will substitute in the given linear equation, I will substitute 9 as the value of x. And then I will get 2 into 9 plus 3y minus 1 is equal to 0. Clearly, this is a linear equation in one variable y, and we can solve for y. We will get a unique value of y. This implies from here we will get y will be equal to 1 minus 18 divided by 3, which is minus 17 by 3. Whatever, I'm not really concerned about the values. Y is equal to minus 17 by 3. So then clearly we can say that 9 comma minus minus 17 by 3 is a root of the equation 2x plus 3y minus y is equal to 0. So similarly, instead of 9, I can choose any other real number, and I will get another corresponding value of y, which will, and then that value of x and y will again be a root of the given linear equation. For example, let x let x1 be equals to 4. So I'm considering not actually x1 equals to 4, but let so how do we I'm explaining how do I find some roots of a given linear equation. So you just assume any real number for the x. So let's say x is equal to 4. Now if I putting the value of x as 4 in the given linear equation, I get 2 into 4 plus 3y minus 1 is equal to 0. This is a linear equation in y. From where I can solve for y, that is, I can find a unique single value of y that will satisfy this linear equation. So from here we get y is equal to 1 minus 8 by 3, which is minus 7 by 3. So this will imply, then I can say 4 comma minus 7 by 3 is a root of the linear equation 2x plus 3y minus 1 is equal to 0. So this way we can find a root of a given linear equation, and we should understand that there are infinite number of roots or solution of a given linear equation of two variables. The next concept is that a linear equation, let's say we have a linear equation in the standard form ax plus by plus c equals to 0. Now, this is not a unique representation of the linear equation. Remember that uh, a linear equation, the set of the set all the ordered pairs, all the roots or solutions of a specific linear equations, they are same. I mean, they are same, but the representation of, by representation I mean the specific values of the constants a, b, and c. I can change the values of a, b, and c in a way such that it will remain the same linear equation. So let's say the given linear equation the standard form is ax plus by plus c equals to 0. Now, if I multiply in this equation, I can always multiply both the sides by a constant real number, non-zero constant real number, and the equation will remain the same. So in this, in that's what I have done in the second this equation, k into ax plus k into by plus k into c is equal to 0, where k is a non-zero real number. Now, this this is so for this linear equation, a a is nothing but a has been transformed to ka, and b is actually kb, and c is actually kc, which are not same. They are different, but it is still the same linear equation. That is, it will give the same set of solutions or roots. Similarly, I can divide the original any given linear equation in the standard form by some non-zero constant, let's say k. Let's so I have ax divided by k plus by divided by k plus c divided by k equals to 0. This equation uh, is will look different because the constants a has now become a by k, the constant b has now become b by k, and the constant c has become c by k. But still, it is the same. It is the same linear equation in the two variables x and y, which will give the same set of solutions or roots. For example, so this is the reason we say that a given linear equation do not have a unique representation in terms of the constants a, b, and c. I can change the values of a, b, and c in such a way that it will still remain the same linear equation. Let's take some examples. Let's say I have x minus x minus y is equal to 0. So this is obviously a linear equation in the x and y in the standard form, where c is 0, where c in this we have a is 1, b is minus 1, and c is 0. Now, I can multiply both the sides by, let's say, 4, and I will have 4x minus 4y is equal to 0. This is the same identical linear equation as x minus y equals to 0, but now the constants a has become 4, the b has become minus 4, and c is still 0. So the representation over here, the representation is different. It is 4x minus 4y equals to 0, and over here the representation is different. By representation I mean the values of a, b, and c, but they are the same. See, they are the same identical linear equation. By that I mean both these equations will give the same set of roots or solutions. Let's say I have an equation root 2y minus 4 by 3x plus 9 is equal to 0. Okay. Now, let's consider some different. Let's let's say I have uh, minus 2x minus 2 root 2 y minus 1 by root 2 or plus 1 by root 2 is equal to 0. So this is a linear equation in x and y in the standard form, definitely, where a is minus negative of root 2, b is minus 2 root 2, and c is 1 by 2 root 2. If I multiply both the sides of this given linear equation by root 2, I will get, so I'm multiplying both the sides by root 2. uh, I have this. If I simplify the LHS, I will have minus 2x minus 4y plus 1 is equals to 0. So this linear equation looks different from the original given linear equation. That is, the representation is different in terms of the constants a, b, and c, but they are actually the same identical linear equation. That is, they will give the same set of solutions or roots. Okay, let's see the next concept. Uh, okay, now uh, we know that the standard form of a linear equation in two variables x and y is ax plus by plus c is equal to 0. Now, uh, if 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 a for some reason is 0, if we put a equals to 0, this will imply that the given equation will become uh, 0 into x plus by plus c equals to 0. This will imply by plus c equals to 0. So if a or b, anyone becomes is equal to 0, then uh, the the equation, the standard form of the linear equation in two variables x and y, will become a linear equation in one variable. So if I consider a to be 0, then we are having by plus c equals to 0. This is a linear equation in one variable y. Now, the question is it still, can we consider by plus c equals to 0 a linear equation in two variables x and y? Uh, to be very honest, I don't know the exact and correct answer, but I will say that actually it is a linear equation in one variable y, because we see there is only one variable y. But if I have to think by plus c equals to 0 as the linear equation in two variables x and y, what I can say now, from by plus c equals to 0, I clearly see that y is equal to minus c by b. So if I am given let's say, okay, let's not consider a equals to 0. Let's say uh, we are given an equation like this, that is ax plus c equals to 0, where obviously a and c are, where obviously a not equals to 0. A is not equals to 0, c could be 0. Now, this equation is definitely a linear equation in one variable x. We do not have y. So can we say this is a linear equation in two variables x and y? I mean, the apparently it looks that it is a linear equation in one variable x. But so from here, definitely we can solve for x. That is the only unique value of x that will satisfy this equation will be x equals to minus c by a. One second, friend. Someone is at the door. Okay, sorry, friend. There was someone at the door. Okay. So this equation ax plus c equals to 0, from here definitely we see this is a linear equation in one variable x, and we know that the linear equation in one variable, the solution, there is only one single solution or root. So root of this equation ax plus c equals to 0 will be minus c by a. So the value of x is minus c by a. Now, if I am asked to, if I have to think this equation ax plus c equals to 0 as a linear equation in two variables x and y, then what will happen to y? Then how do I find a root how do I find the root of uh, the equation ax plus c equals to 0, considering it as a linear equation in two variables x and y? How I know, so definitely I know that the only value of x, I know that x1 comma y1, an ordered pair, is the root of a linear equation in two variables x and y. Uh, but the linear equation in two variables x and y is given to be as ax plus c equals to 0. This definitely means x, the value of x has to be minus c by a. So any root, if I have to consider ax plus c equals to 0 as a linear equation in two variables x and y, then any root of that equation has to be of the form minus c by a, because the value of x has to be minus c by a. Now what will be the value of y? I don't know what will be the value of y, because I cannot find, because there is no y in the given equation. Ax plus c equals to 0, there is no y. How will I find the value of y? How do I find the value of y? I mean, if there was y, I would have substituted the, in the given equation. I would have substituted the one value of x, and from there I would have got a linear equation in y. If there was y in the given linear equation, but there is no y in this given linear equation, how will I find the value of y? How will I find y1? So the concept is that you can consider any value of y, but the value of x has to be minus c by a. So uh, we say that any root or a root of a linear equation in two variables is nothing but an ordered pair. So any root of the equation ax plus c equals to 0, if I if I have to consider ax plus c equals to 0 to be a linear equation in two variables x and y, then any root of that equation has to be of the form minus c by a comma k, where minus c by a is definitely will be a constant value coming from the given linear equation, and the k, you can consider the k can take any real number. The k can take any real number. So we say that all solutions or roots of the equation ax plus c equals to 0 are of the form minus c by a comma k, where k is any real constant. That is, all the roots of the equation ax plus c equals to 0, the x value will always be the same, that is minus c by a, and the k value, that is a y value, the value of y, can be any value. You can consider any real number in place of k. So I can say that ax plus c equals to 0. If this is a, so let's take some specific example. If I am given the equation as 2x minus 1 is equal to 0, so there is no y. So what will be the roots of these? If I am asked what will be the roots of this equation, considering this equation as a linear equation in two variables x and y. Now this is actually a linear equation in one variable x, whose solution is half. So all the roots of this equation, considering it as a linear equation in two variables x and y, will be half comma k, where you put, if now you keep on considering any value or any unique values of real number, any unique values of k, and all those ordered pairs will be a root of this equation. For example, half comma 0 will be a root of this equation. Half comma any, if you take any value, minus 4 will also be a root of this equation. You keep on taking, so since there are infinite number of real numbers, you can take infinite number of values, you can give infinite number of values to k, and then the ordered form, that order will be a root of this linear equation 2x minus 1 is equal to 0. Okay, the next concept is similar. Suppose the given equation is given in the form by plus c is equal to 0. In this case, we do not have x. So if by plus c equals to 0, if we have to consider this as a linear equation in two variables x and y, what will be the roots? So all the roots in this case, so from here, since actually this is a linear equation in one variable y, from here we can easily say that the single value, that the only possible value of y that will satisfy this equation will be minus c by b. So I can consider any ordered pair of the form k comma minus c by b, and this will be a root of the equation by plus c equals to 0, considering it as a linear equation in two variables x and y, where I can for the value of x in all the roots or solutions, that is the ordered pair, the y value will be always minus c by b, with the minus c by b, the minus c by b I am getting it by solving the equation by plus c equals to 0. And for the values of x, I can take any value. X can take any values, and you can give any value to k, and then that value comma minus c by b will be a root of the equation by plus c equals to 0. If we have to consider this as a linear equation in two variables x and y. Okay, let's see. Okay, now this concept, probably this concept is not will not be there in class 9, but I think it will be a good thing if you know this. Suppose you are given two linear equations in x and y. So we have two equations. First one is the a1x plus b1y plus c1 equals to 0. This is a linear equation in two variables x and y, where obviously a1, b1, c1 are obviously in all these cases a1, b1, c1 are all some real constants. Also a2, b2 and c2 are also some real constants. So the first given linear equation in two variables x and y is a1x plus b1y plus c1 equals to 0, and the second equation is a2x plus b2y plus c2 equals to 0. And the question is find the common root of these two equations. That is a root, that is an ordered pair which is a root of both of these two equations. That is, it will be a root of the equation 1 as well as it will be a root of the equation 2. How do I find the common root? Remember that there will be only one single unique common root of two given linear equations. But there is a one thing. There is a one thing to understand is that it is, if you are given two linear equations in two variables x and y, it is not necessary that they will have a common root. Common root may not exist. Now, in what cases, under what conditions, that will definitely depend on the values of the constants a1, b1, c1 and a2, b2, c2. Depending on the constants a1, b1, c1 and a2, b2, c2, the two given equations will have a common root. They can have a common root and they may not have a common root. In the case they have a common root, that is the constants a1, b1, c1 and a2, b2, c2 are such that these two linear equations, indeed there is a common root exists for these two linear equations, then what will be that common root? How do I find that common root? So the steps are from the first given linear equation, you express y in terms of x. So express y, the first step is express y in terms of x from first equation. So this is the first equation, a1x plus b1y plus c1 equals to 0. From here I can say that b1y is equal to negative of a1x plus c1. This implies if y is equal to negative of a1x plus c1 whole divided by b. So I've expressed y in terms of x. So y is equal to negative of a1x plus c1 whole divided by b from the first equation. Now, using the value of y in terms of x that I have got from step 1, I will substitute in the second equation. I will substitute y with the with the um, with the value of x, substitute value of y obtained in step 1. So this is what we have obtained in step 1. We have obtained in step 1, we have obtained the value of y in terms of x from the first equation. That value of y I will substitute in the second equation, meaning uh, in the second equation, if I substitute y with in terms of x that I have got from step 1, it will be a2x plus b2, and for y, it will be negative of a1x plus c1 divided by b, and then plus c2 equals to 0. Now you can see this is obviously a linear equation in x. There is only one variable x, and from here I can easily solve for x. So this is, let's say, from here I can solve for x. Let x equals to x1 be the solution. So from in the step 1, I have found y in terms of x from the given equation 1, and in the step 2, I am substituting in the equation, in the given linear equation 2, I am substituting y with whatever in terms of x that I have got in step 1, and doing that I will get a linear equation in x, and I will solve for x and let the solution be x equals to x1. Okay, now the in the step 3, uh, in the step 3, whatever x1, whatever solution I got in step 2, that is x equals to x1, I will put x equals to x1. I will put x equals to x1 uh, in the first equation. In the first equation, so I will have a1 x1 plus p1 y plus c1 is equal to 0. So this becomes a linear equation in y. I can solve for y. So I'm not solving it because it will be complicated and big. Solving for y. Let y equals to y1 be the solution. Be the solution of, of this linear equation in y. So I got two values, x1 and y1. x1 I got from in step 2, and y1 I got from in step 3. Then I can say that the ordered pair x1 comma y1, or x equals to x1 comma y equals to y1 is the common root of the two given equations, which are these two equations. Which are these two equations? Let's see. Let's try to see this in an example. Let's say I have to see the book for a correct example. I have to take two linear equations which has indeed a common root. Okay, let's see. Let's say the two given equations are 3x minus 2y is equal to 4. This is the first given linear equation in two variables, x and y, and another equation is x plus y minus 3 equals to 0. This is the second equation. Now let's write the first equation in the standard form. So it will be minus 4 is equal to 0. Okay, let's see I hope these two given linear equations will indeed have a common root. So let's say these are the two linear equations, given linear equations in two variables x and y, and I have to find what is the common root of these two given linear equations. That is a root that will satisfy both of these two linear equations. Okay, so step one was to uh, express y express y in terms of x from given equation 1. So I have the given equation is 3x minus 2y minus 4 is equal to 0. This implies I can say 2y is equal to 3x minus 4. This implies y is equal to 3x minus 4 divided by 2. So I expressed y in terms of x from equation 1. Step 2 was uh, put y equals to 3x minus 4 2 by 2 in equation 2 and solve for x So equation 2 is x plus y minus 3 equals to 0. So we have x plus, instead of y, I will substitute the value of y as 3x minus 4 by 2. 3x minus 4 by 2, and I have minus 3 equals to 0. So this is clearly a linear equation in x. If we solve for x, let's solve for x. So we have 2x plus 3x minus 4 minus 6 divided by 2 is equal to 0. That is, I have simplified the LHS. This implies 5x minus 10 is equal to 0. This implies x is equal to 10 by 5, which is equal to 2. This is x1. So putting y as 3x minus 4 by 2 in the given equation 2, I have solved for x, and the value of x is 2. Okay. Now step 3 is I will now put the value of in equation 1, put x is equal to x1, that is 2, in equation 1 and solve for y. So if I put x as 2 in equation 1, I have 3 into 2 minus 2y minus 4 is equal to 0. This is a linear equation and y. We can easily solve for y. This implies 2y is equal to 2. This implies y is equal to 1, which I have referred as y1 in the steps. So I have got step 4, last step, x1 comma y1 is 2 comma 1. So I can say that 2 comma 1 is the common root of the two given equations, that is 3x minus 2y minus 4 equals to 0 and x plus y minus 3 equals to 0. So this is how we find a common root. This is a very simplistic and very basic method of finding a common root between two linear equations of two variables x and y. There are smarter ways which possibly you will learn in the next class, that is in the class 10. I think these are all the concepts that I had to discuss about a linear equation and its solutions. Based on these concepts, I will solve a lot of problems, both from the textbook of author RD Sharma, as well as the supplementary book which is titled MCQs in Mathematics. Uh, I will solve a lot of problems. So the next video will be solving session, and it might be a little longer because I will try to solve as many problems as I can. Not obviously all the problems, but the selected good problems from the two books, and then I will move on to the next concept, the next topic, that is the graph of a linear equation in two variables x and y. I hope this video was beneficial. If it is so, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. I'm ending the video here. Thanks for watching, and until the next video, take care and bye.